All right, this video is on section 7.2, where we dive a lot deeper into discrete random variables and the distributions that go along with them. So a definition of a discrete probability distribution consists of all possible values of the discrete random variable along with their associated probabilities. We saw one of these examples in 7.1 when we were referring to a die, a six-sided die. We were able to compute that probability distribution because it was classical. All the outcomes had the same probability. But not all discrete probabilities have that quality. So discrete probability distributions have two characteristics that I could give you an example where I show you a table and ask you if this fits a discrete probability distribution, and you would be looking for two things. You would be adding up all the probabilities to make sure that they equal exactly 1. And also, the probability of any value must be between 0 and 1. Like we described about the properties of probability have to be between 0 and 1, including 0 and including 1. So let's take a look at this example. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a whole number score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated that they had neither trait, so they were more neutral. The results are shown in the table over here to the right, and our task is to produce a probability distribution for this frequency distribution. So we have the count of employees that scored a 1 being extremely passive to be 24. We have 42 employees out of the 150 tested that identified as neutral, and we have 21 employees that were classified as extremely aggressive. So think about this: if you were owning a company and you wanted to make sure you had a well-balanced company running, you would want to make sure that you don't have overly aggressive people, more aggressive people than anyone else, because that might create a hostile working environment. We also don't want extremely passive people, an overabundance of them, because it's possible not a lot of work will get done. So a good distribution, evenly distributed amongst them, is usually the best mix. So let's take a look at what it would look like to build a probability distribution from this data. You would take the count of employees that were labeled a 1, very passive, over the total number of employees tested to get the probability that the next randomly selected employee will be labeled a 1 is a 16% chance. We do the same for each one of these outcomes, and we receive a probability. Now, again, in order to ensure this is a discrete probability distribution, we add these numbers in the probability row to see that it adds to 1. And we also check to make sure each individual probability is between 0 and 1. So we see they're all between 0 and 1, and when we add them together, it does add to exactly 1. So we would be able, if we were just given this table, we would be able to state, yes, it's a discrete probability distribution. It meets these two characteristics. Another example: consider the random phenomenon of tossing a coin 3 times and counting the number of heads. What is the probability distribution for the number of heads observed in the 3 tosses of a coin? So first, we label X to represent the number of heads in 3 tosses of a coin. We then take a look at this table where we can see that one possibility is that there aren't any heads, 0 heads. Okay, and if you recall from 7.1, actually, I don't remember if it was 7.1 or 6.1, one of the future videos, past videos, we showed that there were 8 possible outcomes in tossing a coin 3 times, and only one of them did not have any heads. So that's a 1 out of 8 chance that we will toss the coin 3 times and not have a single head. There were 3 possible outcomes where head was only showed up once. Notice that these three talk about the order, whether it was the first toss, the second toss, or the third toss. So that's a 3 out of 8 chance that you're going to toss the coin 3 times and get only one head out of those 3 tosses. 3 of the outcomes showed 2 heads, and 1 outcome said that all 3 were heads, and therefore giving us 1/8, 3/8, 3/8, and 1/8 at the probability. All of these are between 0 and 1, and when we add them, 1, 3, 3, and 1, that's 8 out of 8, or 1. KJ Johnson is a computer salesperson. During the last year, he has kept records of his computer sales for the last 200 days. He recognizes that his daily sales constitutes a random process, and he wishes to determine the probability distribution for daily sales. From the probability distribution, he would be able to determine, he would like to determine the following. So here we go. We have sales 0, 1, 2, 3, 4, and the frequency in which he has days with no sales. There were 40. Days that he had only one sale, there were 20, and so on. So the probability, he wants to calculate the probability that he will sell at least 2 computers each day. And subsequently, he wants to calculate the probability that he will sell at most 2 computers each day. So let's take a look at this probability distribution. So we take the original chart and we put the count of days he had no sales over the total days he counted to get, there's a 0.2 or 20% chance that he's going to come up short and have no sales that day. There's a 10% chance he'll have exactly 1, 30% chance he'll have exactly 2, 20% chance he'll have exactly 3 sales, 20% chance he'll have exactly 4 sales. All of these probabilities are between 0 and 1, and when added together, they equate to 1, which verifies that this is a discrete probability distribution. Now to answer the questions he wants answered. What is the probability of at least 2 sales in a day? Well, we take a look at least 2. Think about money. At least $2 in my pocket means that I know I have $2, but I also might have more. So that's including the probability of exactly 2, including the probability of exactly 3, and including the probability of exactly 4. So to get the cumulative probability of at least 2 sales calls, you would add up 0.3 plus 0.2 plus 0.2 to get 0.7, or there's a 70% chance that he'll have at least 2 sales in a day. The second one, we were asking about the probability of at most 2. So again, think about your money. If I know I have at most $2 in my pocket, that means that I'm not even sure I have $2. I might not have anything, I can't remember. But I definitely know I don't have more than $2. So that means including I have no money, or he has 0 sales in a day, exactly 1, or exactly 2. So we add up 0.2 plus 0.1 plus 0.3 to get the cumulative probability of 0.6, or there is a 60% chance that he'll have at most 2 sales in a day. Another example, an investor has decided that she will purchase a stock if there is at least a 50% chance that the price of the stock will be more than $32 in 30 days. Assuming the price of the stock 30 days from now is described in the table below, should the investor purchase the stock? So we see here that X is defined as the stock prices, and P of X is representing the probability that the stock prices will be this particular price 30 days from now. So that's what this is saying. These are the probability that the stock will be worth $30 is a 5% chance. The probability that the stock will be worth $33 is also a 5% chance. So if I was to read this, the highest probability is 0.25, or a 25% chance. So it looks like it's most likely, if we're looking at single probabilities, that it would be worth $31.50, which doesn't technically meet her $32 threshold. So letting the random variable represent the price of the stock 30 days from now, if we're taking a look at the probability that the price of the stock will be $32 or greater, then if we look back at the chart, $32 or more are these last three probabilities. So we would add up 0.2, 0.15, and 0.05. And that gives us, oh, sorry, excuse me, more than $32. Is that what she stated? More than. Oh, I missed that. Keyword more than. If I need more than $32, it means $32 is not going to freaking cut it. I need 32.01 and 1 penny or more. So that means we're technically only looking at these last two slots here, the $32.50 and the $33. So we add 0.15 and 0.5, and we get a 20% chance that that's going to happen. Now, it depends on whether you're an optimist or a pessimist on whether you would decide to go ahead and buy that stock. But since the probability that the price of the stock will be more than $32 in 30 days is only 20%, it's unlikely the investor is going to purchase the stock. Each of the discrete distributions possess a probability distribution function. These functions assign probabilities to each value of the random variable. So the following function is a discrete probability distribution function where we're seeing the possible outcomes, and we would use these outcomes if our random variable was equal to 1, 2, or 3, or 4, and we'd apply the probability of 0 everywhere else. We're not necessarily going to be diving into discrete probability distribution functions all that much, but we will do a little work on it in the next couple sections of chapter 7. Oh, there's a solution. What was the question? Summarize the probability distribution for this function. Okay, so this is what the function's really saying, that if x equals 3, you put 3 into the formula. I'm going to head back. So you put 3 into the formula. 3 squared is 9. 9 over 30 is the probability. And that works for when x is 1, 2, 3, or 4. Anything else, we would just say the probability was 0. And here is the distribution, x being 1, x being 2, x being 3, x being 4. We see that these add to 1, and each one of these probabilities exists between 0 and 1, making it discrete. Now, something else we want to discuss when referring to discrete probability distributions is how to calculate the mean of a probability distribution with the random variable x and the associated probabilities to that random variable x. So what this formula is saying is that the mean, mu, can be calculated by adding, this little fancy e means add them up, the products of each individual x multiplied by its associated probability. It's fairly easy to do out by hand, and I have some examples in this video showing you how to do it out by hand, because in some cases that actually might be faster than using our guru. But for the sake of the fact that we use our guru a lot in this class, I wanted to make sure that you do know that our guru can calculate this for you. In fact, we've already done this once before. We did it when we were talking about calculating our GPA, so our weighted mean, and it's the exact same process. So here we have our random variables 1, 2, 3, 4, and 5 with their associated probabilities of 0.16, 0.22, 0.28, 0.2, and 0.14. I believe this references back to that personality test that we talked about in a previous time. I can't remember if it's this video or another video, but we talked about a personality test and how to calculate the probability distribution. I believe it's in this video. So let me now switch over to our guru before we continue with the rest of the PowerPoint so I can show you how to calculate this using our software. So we would want to log in to ourguru.com. Now, because this was a really small set, for me, I think it's easier to just create it real quick in our guru than to try to make it an Excel file and import it. So I'm going to go to data, I'm going to go to data import, and I'm going to create a new data set. So for this first variable, this is going to be my x's, my random variable x. And I need, let's see, I have 5 of these. So we have an x of 1, 2, 3 being neutral, 4, 5 being very aggressive. And then variable 2, I'm going to label as the p of x, the probability of the random variable x occurring. And I'll type in the values from the PowerPoint, 0.16. Oops, I hit enter instead of the down arrow. 0.22, 0.28, 0.2, and lastly 0.14. Okay, I'm going to save this as, I'm going to save it as probability, let me be more specific, discrete probability distribution. I'll just leave it at that. Discrete probability distribution, save. So once I hit save, it's going to now show up in my list of data sets. So if I double click, as I've told you guys, every single time I work in our Guru, I always double check that my x's, my p of x's, that they properly imported, that my labels are up here, and my data values are in the white cells. So now I want to calculate the mean. What is the average personality score based off of these employees that were surveyed? So we come over here to functions under data. When I click summary statistics, I'm going to select this data set I just made. And then I'm going to need to select the numerical. When you guys are doing a summary statistics of just one variable, that's all you needed to select was what variable do you want the mean, the median, the mode to be calculated for. But when you're working in a distribution such as this one, you also need to recognize what is the frequency. So recall back from the GPA example, the grades, the points that we got for the grades we got in the class were the numerical, and how often that grade was applied was the credits that the class was worth, or how many hours the class was worth. For here, our personality traits are our x variable, and the frequency is the probability that they occur. So look here, if you need standard deviation, if you need variance, you can select those. I don't need the quartiles in this case. I pretty much just want the mean, the variance, and the standard deviation, because that's pretty much all I need to work with this particular set. So I'm gonna hit my eyeball. I guess it wants me to have a lot more. So let me, here we go. Let's see if that works. Px is not a proper frequency variable. Frequency should be all non-negative and some non-zero values. Let's go back to the chart. They're all non-negative and they're all non-zero. So that's strange. I don't think I've ever had it tell me that before. Preview anyway. Not proper frequency variable. Okay, I'll get back to you guys on that one. For some reason, this is giving me a problem. I'm sure it's something I just can't see while I'm lecturing, but I will get back to you on our Guru and what was going wrong with that. But for now, let's head back to the PowerPoint. So if we were to do this out by hand, then we would multiply 1 times 0.16 plus 2 times 0.22 plus 3 times 0.28 plus 4 times 0.2 plus 5 times 0.14. And when we add those products up, we get 2.94, or approximately 2.9, which is a good average to know as an employer. I would say that I have a good average, because the average comes around the neutral of 3. Now, if it's a much larger set and you're trying to do this, you can do this in your calculators as well, and you can also do it in Excel. I'm going to figure out why our guru is giving me an issue. And again, I'll get back to you on where my issue lied, but that should be the process that will produce a mean for a discrete probability distribution. Expected value is another name for the mean of a discrete probability distribution. And let's take a look at an example. So actually, I'm going to cover this example first. Suppose you are confronted with two investment alternatives that possess uncertain outcomes described by the probability distributions given in the table on the next slide. Which option should you choose? So this is very real life here. Let's say that you had two options to choose from to invest in. There's option A, where the profits range from losing $2,000 to gaining $4,000. Or option B, where you could lose more money in option B at $3,000 and gain the same amount, $4,000 as a max. Now, when I look at this, it's very difficult to make a decision. Some of us may be automatically saying option A seems like there's a less money that I could lose out of it, and therefore I might want to go with option A. But if we calculate the expected value of our investment, by calculating the average, which again would be taking each value and multiplying it by the frequencies and adding them up, and that's shown here, which for now we'll have to do out by hand because it doesn't look like our guru likes me very much for doing this. It comes out to $900 is the expected value of your investment if you go with option A. If we go with option B, the expected value is $1,400. So even though there is a chance that I could lose more money with option B, the expected value, or the average value of investing in option B is $500 more than option A. And therefore, if you're going to invest, you might as well go with the one who has a probability of a higher output. Let's take a look at the example and let's do this one out together. So if we're at a raffle where 1,500 tickets are sold, and they're sold at $2 a piece. This raffle will produce 4 prizes: $500, $250, $150, and $75. You purchase one of the tickets. Find the expected value of that ticket you are holding in your hand. So let's walk through all of these steps in order to calculate this. And I want to do this one with you so you understand how to do this from the jump. So remember, the first step to calculating would be to list all of the expected outcomes. Well, let's see. I'm holding my ticket that I purchased for $2. And let's say that my ticket gets called and I won $500. Now, $500 is not the expected value, though, because you have to take into account that you bought a ticket for $2. So technically, the expected value is $498. Okay, the next thing that could happen is I win the $250, which again, I subtract the cost of the ticket. The expected value is $248. If I won the $150, the expected value would be $148. If I won the $75 prize, my expected value would be $73. And lastly, I could lose, which means I would win no money, but the expected value would be -$2 because I still bought that ticket and they don't refund you just because you lose. Would kind of defeat the purpose of the raffle. So now the next step would be to find the probabilities of each one of these outcomes occurring. Well, there's only one $500 prize, which means only one of the 1,500 tickets are going to win it. So there's a probability of 1 out of 1,500. Same thing for each one of the prizes. There's only 1 out of the 1,500 tickets that are going to win each of these prizes. So they're all a 1 out of 1,500 chance to win, which when you think about it, that's really not very likely. Now, how many people are going to lose? Well, there's 4 prizes, 1,500 tickets. So 1,500 minus 4 is 1,496. So there are 1,496 tickets that will be losers out of 1,500 total tickets. giving you a very high probability of losing. Now, to calculate the expected value of the single ticket that you're holding would be the same as calculating the average outcome. And in order to do this for a probability distribution, we take 498 and multiply it by 1 over 1500. Again, this really should work in our guru, and I'm really disappointed that it didn't work out for us today. Plus 248 times 1 over 1500 plus 148 times 1 over 1500 plus 73 times 1 over 1500 and plus -2 times 1496 divided by 1500. When we add these all up, we will get our expected value of the ticket we're holding. So let me do that real quick in my calculator. So I have 498 times 1 divided by 1500 plus 248 times 1 divided by 1500 plus 148 times 1 over 1500 plus 73 times 1 over 1500 plus -2 times 1496 divided by 1500. I get an expected value of -$1.35. Now, what the heck does that actually mean in real life? It means that every person holding the ticket is expected to lose $1.35. Now, that doesn't make much sense because I'm either going to lose $2 or I'm going to win a prize. But really what this is telling you is if I was the person running the raffle, this would tell me that I would make $1.35 off of every person, even when all 4 prizes are paid out. And that's important to know because if this number was not in the negative and you were the person running the raffle, you would not be making any money. You would be handing out $1.35 to every person if it was a positive outcome. So this is really important for us to see that if you're running a raffle, typically raffles are run because you want to make money. Even after the prizes are given out, the total cost of the prizes, and therefore the expected value being in the negative is important. Okay, here are the ugly formulas for variance and standard deviation. I will find a way to get it to work in our guru. I do not expect you to do these formulas out by hand. If for whatever reason our guru isn't making it work, then I will show you how to do this in our calculators or in Excel. I'll have to do Excel because I didn't require all of you to get calculators. It's very easy to do in the calculator, but I will make sure to include a video on Excel if I can't get the Art Guru to work. Either way, there'll be another video when I figure it out. All right, talk to you guys later.